If no one touches you in space, will you just float forever? That bizarre question is exactly what Newton answered, centuries before space travel even existed. Let's unlock force and Newton's 3 laws of motion. What is force? It's simply a push or pull. But here's the twist. It's not just any push or pull. Force is a vector quantity, meaning it has both magnitude and direction. The SI unit of force? The Newton N, named after the legend himself, Sir Isaac Newton. By the way, did you know that 1 Newton is the amount of force required to accelerate a 1 kilogram mass by 1 meters per second squared? That's the same as the force needed to nudge a mango across your table. There are 3 Newton's laws of motion. Newton's first law, aka the law of inertia. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. Here's a challenge. Place a smooth object, like a pen or toy car, on a book and tilt it slightly. Watch how it moves. Now place the same object on a rough surface. See the difference? That's inertia in action and friction as the unbalanced force. This law is often summarized as an object at rest tends to stay at rest and an object in motion tends to stay in motion. For instance, imagine a book sitting on a table. It will remain stationary unless an external force, such as a push or a pull, is applied to set it in motion. Similarly, a ball rolling on a frictionless surface would continue rolling indefinitely in the absence of any external force acting upon it. This law is why you lurch forward when a car suddenly stops. Your body wants to keep moving. Whether it's satellites orbiting Earth or your morning coffee spilling when the bus jerks, inertia is everywhere. Next, Newton's second law of motion. Newton's second law of motion states that the force applied to an object is directly proportional to its mass and acceleration. Challenge 2. Find 2 objects of different masses, like an empty backpack and the same backpack filled with books. Try pushing both across the floor using the same amount of force. Which one accelerates more? That's Newton's second law in real life. More mass means less acceleration if force stays constant. The law establishes a quantitative relationship between the force acting on an object, the mass of the object, and the resulting acceleration. The law is mathematically expressed as force equals mass times acceleration, or F, is equal to ma. In practical terms, it implies that a greater force is required to accelerate a more massive object, and on the other hand, a smaller force will produce a greater acceleration in a less massive object. Finally, Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction. This means that if object A exerts a force on object B, then object B simultaneously exerts a force of equal magnitude in the opposite direction on object A. The final challenge, sit on a wheeled chair or skateboard safely. Now place your hands against a wall and push. What happens? You roll backward. That's Newton's third law. Your push action on the wall creates a push reaction back on you. Simple, powerful, and kind of fun too. This law emphasizes the symmetrical nature of forces and interactions between objects. For instance, when a person walks on the ground, the action force is the push exerted by the foot on the ground, and the reaction force is the ground pushing back on the foot with an equal force in the opposite direction. Another example is the recoil of a firearm. When a bullet is expelled from the gun, the action force is the forward motion of the bullet, and the reaction force is the backward kick felt by the shooter. Similarly, in rocket propulsion, the expulsion of gases downward generates an upward reaction force that propels the rocket forward. This law explains everything from jumping to jet propulsion. It's the great equalizer of motion. How do you calculate the force acting on an object? As stated by Newton's second law of motion, when a force acts on an object, it produces acceleration, with the object moving in the direction of the force. The acceleration is directly proportional to the force and inversely proportional to the mass of the object. The formula for calculating force acting on an object is force is equal to mass times acceleration. Let's consider some examples. What's the force acting on a 2,000 kg car accelerating at 4 meters per second squared? We've seen that force is equal to mass times acceleration. The mass given is 200 kilograms, and the acceleration is 4 meters per second squared. 2,000 times 4 gives 8,000 newtons. Therefore, the force acting on a car is 8,000 newtons. The second example. What is the mass of a football when a force of 40 newtons accelerates it to 20 meters per second squared? Force is equal to mass times acceleration. The question asks about a football's mass. Therefore, the formula becomes mass is equal to force over acceleration. The force given is 40 newtons. The acceleration given is 20 meters per second squared. 40 over 20 gives 2 kg. Therefore, the mass of a football is 2 kg. The final example. A 65 kg swimmer pushes off a wall with a force of 300 newtons. What is his acceleration? The question is asking about the acceleration of a swimmer. Therefore, the formula is acceleration is equal to force over mass. The force given is 300 newtons. The mass given is 65 kg. 300 over 65 gives 4.64 meters per second squared. Therefore, the acceleration of a swimmer is 4.64 meters per second squared. To recap, force is simply a pull or push. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. Newton's second law of motion states that the force applied to an object is directly proportional to its mass and acceleration. Newton's third law of motion states that for every action, there is an equal and opposite reaction. Newton showed us that forces move objects, but what happens when they make things rotate instead? That's a whole new level of motion. In the next video, we dive into the moment of force, what makes doors swing, levers lift, and wrenches turn. It's torque time. Stay tuned. Stay curious.